This is a super duper summary of S block decompositions. If we have group 1 metal carbonates, except lithium of course, as we know, as we seen before, with this symbol I have indicated group 1 metals except lithium. With this symbol I have indicated lithium and other group 2 metals. With this symbol I am indicating more precious metals like silver, mercury, gold and platinum. So if we have take a group 1 carbonate except lithium, and it does not thermally decompose into anything. But if we take lithium or group 2 carbonates, it will thermally decompose to form the metal oxide and carbon dioxide, while a precious carbonate will thermally decompose to produce the precious metal itself, oxygen gas and carbon dioxide. Group 1 metal hydroxides except lithium do not thermally decompose just as with carbonates. However, lithium and other group 2 metal hydroxides will thermally decompose to form the metal oxide and water, specifically steam. You see over here, group 1 metal nitrates except lithium will thermally decompose to form the metal nitrite and oxygen gas. You see, because that's this thing, because group 1 metal nitrites do not thermally decompose just like carbonate and hydroxides, so it will remain in this state. However, with lithium and other group 2 nitrates, the nitrite thermally decomposes into the oxide and nitrogen dioxide. So thereby from the nitrite will form, and the nitrite will further thermally decompose to form the oxide and nitrogen dioxide. So thereby totally lithium and other group 2 nitrates will thus resultantly thermally decompose to form the oxide, nitrogen dioxide and oxygen gas. If we take a precious nitrate, it will thermally decompose to form the pure metal itself, oxygen gas and nitrogen dioxide. Metal peroxides thermally decompose to form the metal hydroxide and oxygen gas, while metal superoxides will thermally decompose to form the metal oxide O2- and oxygen gas. If we were to take a precious superoxide, however, it won't form the oxide, but it will form the metal itself and oxygen gas. While if you were to take a precious chloride and thermally decompose it, it will form the chlorine gas and the pure metal itself. I think it can be figured out, like, but I have highly condensed it, so basically, like, I think you could figure out, like, what I meant is like something like, if I have silver chloride, it will thermally decompose to form silver and chlorine gas, and if I were to have magnesium nitrate, it will thermally decompose into form magnesium oxide, nitrogen dioxide and oxygen gas, and so on. Group 1 oxalates will thermally decompose to form the carbonate and carbon monoxide gas. As we have seen here, the group 1 carbonate cannot thermally decompose, and that's where it stops. However, the group 2 carbonate, including lithium, will thermally decompose to form the oxygen and carbon dioxide. And yes, thereby by thermally decomposing the group 2 and lithium oxalates, we will obtain the oxide, the carbonate and carbon monoxide because the carbonate decomposes into the oxide and the carbon dioxide. If we were to do partial decomposition, we will be able to get the carbonate because it's relatively stable. Bicarbonate, group 1 bicarbonates except lithium will thermally decompose to form the group 1 carbonate, carbon dioxide and water. The carbonate does not decompose further. Even if we like partially decompose group 2 and lithium bicarbonates, we will still get the carbonate because it's relatively stable. But if we were to heat further, the carbonate will decompose into the oxide and carbon dioxide, and thereby we will, at the end of the day, the group 2 metal bicarbonate will thermally decompose to form the metal oxide, carbon dioxide and water. The metal permanganate will thermally decompose to produce the metal manganate, the manganese dioxide and oxygen gas, while the metal chlorate will thermally decompose to form the metal chloride and oxygen gas. If we were to take the metal thiosulfate and thermally decompose it, we will obtain the metal sulfide and sulfur trioxide. If we were to obtain lithium or group 2 sulfates and strongly heat it, we will be able to obtain the metal oxide and sulfur trioxide. These are reactions forming sulfur trioxide. If we were to take an ammonium salt and thermally decompose it, we will get the anionic acid of that said salt and ammonia gas. Well, except these are exceptions. What do I mean by ammonium salt? Basically, if I were to take ammonium chloride, it will make hydrochloric acid and ammonia. Here, if I take ammonium carbonate, it will form carbonic acid H2CO3 and ammonia gas. If I were to take ammonium sulfate and thermally decompose it, I will get sulfuric acid and ammonia gas. You remember the carbonic acid? Because of it's hot, it will thermally decompose into water and carbon dioxide. That's a small exception. If I were to take ammonium nitrite and thermally decompose it, I will get steam and nitrogen gas. But if I were to do so with ammonium nitrate, I will be able to get steam and laughing gas, N2O. It's the only reaction in our syllabus which involves in making this. Now this is an interesting reaction. This is the green color ammonium dichromate. If we thermally decompose it, we'll be able to get the green chromic oxide and we'll get steam and nitrogen as well. It's a nice reaction. Check it out, really. Decomposition of ammonium dichromate. It's quite a sight to see. And lastly, ammonium chlorate will thermally decompose to form nitrogen gas, chlorine gas, oxygen gas and steam. And this was a super duper summary of S block decompositions.